okay, people invented something called a wheel, okay? Right? They use the wheel to do what? To build carts. Okay? I need you to erase so nothing's on there. To make carts. They put two wheels together, right? Now you have a little cart here that you can pull and take things with. Eventually they put what? An engine on the car, and the car on the cart. And what does the car become?
A car.
A car. This has been happening for many years, okay? People build on other people's inventions. Got it? Okay. When people decided to make wheels, one thing was clear, that they needed to be what? No, ways to measure things. Because things needed to be the exact same what? Size or distance. And we wanted to know how far from here to there. How much does this weigh compared? How much does an apple weigh compared to an orange? Or how many 12 oranges weigh versus another 12 oranges. So then units of measurement started to happen. For example, here's an easy unit of measurement that you can use, okay? Palms. Pay attention, which one we got? You filming this?
Oh, yeah.
Let's see how many palms take the whole board. Ready? Count with me.
1, 2, 3, 4, 5.
5 palms. Okay? Devin, please stand up. Let's see how many of your palms cover the whole board. 1,
2, 3, 4, 5, 6, 7.
Thank you, Devin. What's the problem with that type of measurement? Marcus.
Some hands are going to be bigger, some hands are going to be smaller.
So when I say, hey, 5 palms, right? Is it a good statement? Is it an accurate statement? It's not very accurate, right? Now, pay attention. So maybe we have 5 palms here. Okay, then people started getting things as decided to come up with different measurements, like rulers, right? And every time you see a ruler, most kids' rulers are what?
12 inches.
Are what? 12 inches, which equals what?
1 foot.
1 foot, okay? About 1 foot, right, is a ruler. I have 10 inch for a foot, right? It doesn't mean that it's not here. 1, 2, it's not like the palms, right? It's what? 12 inches. And then you see all those little lines inside, right? What are those?
Half.
Huh?
Benchmark fractions. Oh.
Those are fractions of inches. Understand? Got it? 1/10 of an inch, 1/8 of an inch. Okay? Half of an inch. But we know that 12 what? Equals what? Okay. Now if you turn that ruler around, what do you get? Centimeters. And what do we have inside the centimeters? We have smaller lines, right? Which are millimeters, okay? And millimeters are fractions of what? Centimeters. For example, how many millimeters to get to a centimeter? 10. Yes, 10 millimeters to be equals what? 1 centimeters. Okay? After the centimeters, we got decimeter, right? How many? That's one that not a lot of people use. But how many centimeters to get to the decimeter?
100.
No, 10. Let's watch the push-ups. How many centimeters to get to a decimeter? 10. How many decimeters to get to a meter? 10, right? So how many centimeters to get to a meter? 100. So now a meter would look like what? 3 rulers. About 3 rulers, right? Because each ruler has about 30 what? Centimeters. So 60, 90, and a little more. That's about a meter, right? Got it? So let me ask you a question. How come we measure things in inches and then we measure things in centimeters? Why do you have 2 different types of measurements?
Well, because sometimes we can measure something that is smaller than inches, so we get a measurement smaller.
Well, we can use, that's good, I mean, that's true. Sometimes we need more things that are a little more precise. I And in that case, the metric unit will be a little bit better, okay? Because we have two systems. We have the English system, right? And you have the metric system. Repeat that with me. We have the English system and the metric system. Okay, so that's one reason why we measure things, right? We have two different ways. We need to measure things that are a little smaller. What's the other reason? Is there another reason? The other reason is because culture, for many years, people have been measuring things a certain way, right? And it has been passed down, and people have gotten used to it. Understand? For example, the United States, we use the English system, okay? This system was probably passed down from, you know, when the English came to the United States and pilgrims and everybody else, right? But it's as old as the Babylonians and the Egyptians, you understand? Actually, something a lot of people don't know is that the metric system of centimeters, millimeters, was only developed about 300 years ago, okay? And the reason was this was developed is because he wanted the whole world to speak the same language, right? In terms of measuring things. Because if you measure things in inches, right? And I measure things in centimeters, then we have to convert from inches to centimeters. So we need equations, and that takes time. Here, to sit properly. Back straight. Does that make sense?
Yes, sir.
But when we look at the whole thing, okay, when we look at a ruler, it's not a very short ruler, right? And we have 0 centimeters here. 1, 2, 3, 4, 5, 6, 7 millimeters, right? And that's 1 centimeter. We know that what? It takes 10
millimeters equals 1 centimeter.
Right? 10 millimeters equals what?
1 centimeter.
And that's what? Precise. And that 10 metric unit will be a little bit better. Equals what? Okay? 1. Right? If I say I have 5 milliliters, no, sorry, millimeters, what is that equal to centimeters?
Wait.
1/2 of a centimeter, right? What's 1/2? 1/5. You guys see that? Yes or no?
Yes, sir. Yes.
If I say I have 3 millimeters, what does that equal? Right?
Yeah.
We got what? 3 out of 10, right? Just a fraction, right? And that is equal to what? 0.3. Because the nice thing about the metric system is in the units of 10, 100, 1,000, 10,000, 100,000, 1 million, right? So this makes it very easy to divide. Does that make sense?
Yes, sir.
100 of these equals. Now, let's take a look real quick at another way that we could express fractions. 1 inch, 0 inch. How many little lines do we have on the inch?
16.
Right? 16s, right? 1/16 of an inch, right? Does that make sense?
Yes, sir.
So, /16, 1/16 of an inch. Now, so when we have 8/16 of an inch, right?
Sir.
This little space is what? 1/16 of what? Of an inch, right?
Yes.
So then from here to here, what do we have, Kieran?
So we have 1/2.
1, 2, 3, 4, 5, 6, 7, 8. 16 of an inch, which is equal to what?
1/2.
1/2, right?
Yeah.
And then of course we divide it 1, 2, 3, 4. We do a little bigger line, so we can say 1/4 of an inch, and so forth, right? But in theory, the inch is divided in the ruler with how many measurements? 16, right? So in the other one, it went from 0 to 10, right? In this one, it goes from 0 to what?
16.
16. Okay? How many seconds in a minute?
16.
The time is 0 to 60, right?
Yes, sir.
How many days in a year?
365.
So it goes from 0 to what?
365.
So how many days have passed so far? We're the 9th, right?
Yeah.
So far we have lived out of this year 9 out of 365. What time is it right now?
412.
It's 4:12. How many days in an hour?
24.
How many hours in a day?
24.
24. How many hours of the day have we lived so far?
8.
12. 12
12 minutes.
plus 4, right?
16.
16. So we have how many minutes?
12.
16 and 12 minutes. But listen, I didn't ask you how many minutes, I asked you how many hours. So what do we have to do? No, we need to convert those minutes to what? To hours. What is 12 minutes in hours? We gotta do the math, right? It's not exactly 1/5. So 12 minutes is what? 12 out of what? 0 to what? 60. We have 12 over 60, right? That's the fraction. Then we simplify, and what do we get? 6 over what? 30. Right? Divide everything by 2. To simplify a little more, what do we get? 3 over what? 3/10, right? So then we know that we have 60 hours with this so far and 3/10 of an hour. Right? What?
Couldn't you 1/5 is 5 times 12 is 60?
5 times.
12 is 60.
Okay? Alright, let me see real quick. 12 minutes out of 60. Oh. No, you're doing it backwards. Pay attention, okay? Pay attention. Okay? Because it's not how many times goes into 60, because it's not 60 divided by 12. It's 12 divided by 60. You understand? Oh, so you need to think before you interrupt. Raise your hand. Do not do that again. Do not do that again. Raise your hand. So now we have 16 and 3/10 of an hour. But what is really 3/10? We need to find out, right? So how do we do that? How do we put 3/10 into decimals? Into little numbers like 0.5555 or 0.333. How do we do that? Very simple. We have to divide, right? Let's do that real quick. 3 divided by what? 10. Right? That was our answer. We're going to take a fraction to a decimal. Or we could also take a decimal to a fraction, right? 10 divided by 3. What number multiplied times 10 gives me 3? Corey? 0. Okay. 0 times 10. 0. I have now what? And 3. Oh my God. But this goes forever. That will keep getting zeros, right? But now I need to bring down a number, right? What number do I bring down?
0.
Wait. I gotta borrow that number. So I have to put a dot. Then I get the 0. Right? So I get the 0, borrow it down, and now I have what?
30.
Then the question becomes, what number multiplied times 10 gives me 30? 3. And then what do we get? 30. We got 0 here. And if one of you was a number, we keep going, right? Decimals can go on forever. Okay? Some decimals like 0.3333333. It just keeps going on forever. And the way we write that is 0.33 with a little line on top. Got it? Now, then we know that we have, so far we live what? 60 what? Hours and 0.3 of a day. Right? So the first thing, guys, the first thing that we have to do is first we need to find out what scale. The thing about the metric system that is nice is that it uses what? Units of 10 instead of 16, 12, 365. For example, 365 times 48. Do it in your head real quick. It's hard, right? But what if I say 100 times 10.
Oh, easy. 1,000.
10,000. 10,000 times 10.
100,000.
100,000. 100,000 times 10. A million. 1 times 10. 10 times 10. 100 times 10.
1,000.
1,000 times 10.
10,000.
10,000 times 10.
100,000.
100,000 times 10.
A million.
Right? A million times 10. 10 million. Understand? In distances, what is the way that we measure things in the English system? Inches. Right? English, we go inches, foot, miles. Meters is not part of the English system. Understand? How many inches to a foot?
12.
How many foot to a yard?
3.
How many yards to a miles?
1,000.
No.
100. 10,000.
Yeah, because I just know this rule, okay? 5 tomato, okay? And what it says, 5 tomato means 5 so 2 8 oh 5 tomato 5 tomato, right?
5 tomatoes.
So we know that there's 5,208 feet in what? In a mile. And if I want to compare miles, this feet to yard, what do I have to do? Divide by 3, right? So let's do it real quick. 5280 divided by 3. What do we get? You should be filming more here. 3 times 5 what? 1.
Minus 3 equals 2.
Raise your hand. What do we do now? We bring down?
2.
Then what do we multiply? 3 times what?
7.
7. 21. What do we get next?
1.
What do we bring down?
8.
3 times what?
6.
Okay, 3 times 6 equals what?
0. 18.
0. What do we bring down?
0. 0.
So, 0. 0. So how many yards to a mile? 1,000. What? 760. Okay? Now let me ask you a question once again. 1,760 times 50. How much is it? It's hard, right? It's hard, right? Now let's look at the English system. First thing we have what? Millimeters. To what?
Centimeters.
Sorry, the metric system. Millimeters to what? Centimeters. Centimeters to what?
Inches.
To what?
Meters.
In reality, it's what? Decimeters. Even though it's not used a lot.
And then comes meters.
Then comes what?
Meters.
Meters. Okay? And then comes kilometers. But before kilometers, yes, for sure. We have something called deca and hectometers, okay? Now that's something you're not going to learn. We got deca, hecto. So let me write it again. Repeat with me. Millimeters. Centimeters. Decimeters. Meters. Deca. Then what? Hecto. Then what? Kilometers. Okay? And listen. There are more names that way that you haven't learned yet, and there are more names that way that you haven't learned yet. Okay? Got it?
Yes, sir.
From millimeters to centimeters.
10.
From centimeters to decimeters.
10.
From decimeters to meters.
10.
Hey, be quiet. From meters to decimeters.
10.
From decimeters to hecto.
10.
From hecto to kilometer.
10.
Next question. Pay attention. From millimeters to meters.
30.
No.
1,000.
Because remember, 1,000. Because 10 equals 1. So we have 10 of the other one. 10 times 10 equals 100. And if you have 10 of the other one is 1,000, right?
Yes.
Does that make sense? Yes? Alright, let's see. How many millimeters 2 kilometers.
10,000.
Let's do it. 10 times 10 times 10 times 10. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 5, 6, right? And if we do from here, we say 1 million. What do we do to do from here to here? It takes 10, right?
Yes, sir.
Let me ask you a question. If I have a 5 and I multiply it times 10, what do? I add a 0, right? Right?
Yes, sir.
So let's get this 10. I multiply it times this 10. What do I get?
100. Thousands. 10,000. 100,000. 1 million.
Right? So how many millimeters equals a million?
Million.
How many millimeters equals a kilometer?
A million.
How many millimeters equals a kilometer? I don't hear you. What?
Million.
So what fraction is 5 millimeters out of a kilometer? 5 over what? A million. Does that make sense?
Yes, sir.
Right?
Yes, sir.
Now, if I say 100 centimeters times centimeters, centimeters, same thing. Hey, if I say 100 meters times 5, how many meters we got?
500.
You see how easy it is to multiply? Okay? Now what you need to understand is here we're working what? From 0 to what?
1 million.
To 0 to 10, to 0 to a million, right? And that's your scale, right? So let's do some math problems now, okay? Real quick. And that's the last thing we're gonna do, then we're gonna play.
Yeah.
Let's look at one of Devin's problems in his book. Devin had this one. He had one problem that says 420 meters, and we need to convert that to kilometers. How do we do it? First we need to know what? The scale. And what's the scale? 1 meter equals how many kilometers? I mean, 1 kilometer equals how many meters?
1 million.
If you don't know your scale, we have big problems, right? Let's do it again. Millimeters.
Millimeters.
Centimeters.
Centimeters.
Meters.
Meters.
Sorry, I jumped one. Decimeters.
Centimeters.
Meters.
Meters.
Then what? Deca. And then what? Hex, whatever. And then what? Kilometers. From here to here, what? From here to here, what? From here to here, what? 10 times 10 times 10?
300.
So 1 meter equals how many meters do we need to get to kilometers?
1,000.
1,000. Okay, you do this thing and you could always figure it out. You have your own conversion, right? So 1 kilometer equals how many meters?
1,000.
Right? So 420 kilometers divided by what?
1,000.
Out of 1,000 is going to tell us what? The fraction, right? How do we simplify that? How do we simplify that?
Divide it.
Well, we could take the 0 by 0, we could divide by 10, and now have 42 over what?
100.
We could divide this by what? By half, right? And what do we have? What do we have?
21 over 50.
21 over 50, right? And then what do we do after that? Try to divide by what? Maybe 3?
Yes.
Does 3 go into 50? Think about it. Let's do the math. Does it?
5.
Alright, let's try it. So 50. 3 divided by 50. Sorry, 50 divided by 3. All times 0. Then I have to divide 20 divided by 3. Does 20 go into 3? No, right? Okay. So we got 21 over 50. We can no longer simplify that equation. Let's divide 21 divided by 50. What number times 50 gives me 21?
0.
0, right? 0. I bring the 21 down. Put the dot. Borrow the other 0. What number times 50 gives me 210?
4.
4. Bring another 0. What number times 50 gives me 100?
2. And then it's going to keep on going 0, right?
No. Sit. 0. And then we're done. So it turns out that 420 meters equals what? 0.42 what? Kilometers. Now that's an easy way, so you don't have to do it this way all the time. When you divide or you multiply a number by, so all this mean the same, right?
Sir.
Okay, so when I say divide it, you know that I mean this, I mean this, I mean this, and I mean that, right?
Yes, sir.
Yes?
Yes, sir.
Awesome, what do we do?
Move it over 3 times.
1, 2, 3. Right? Get it?
Yes, sir.
0.005. Okay? 420 meters to what? 2 kilometers. Right? What do we have to divide 420 by? By 1,000, right?
Yeah, 1,000.
What do we know? That 420.0 divided by 1,000, how many times do we have to move it?
3. 0.420.
You see how easy it is? You see? We don't have to do a long division. Because that's what happens with the metric system. Let's do a last example. Devin has here one in the book. And in the book it says 1,183 meters to kilometer. 1,183 meters to kilometers. What do we have to divide by?
1,000.
Divide this by 1,000, right?
Yes.
So how many times do we need to bring this?
3.
1, 2, 3. Right?
Sir.
So what's the answer?
1.9.
1,983 meter is equal to 1.9 what? 83 kilometers. You see how it works?
Sir.
But remember, the first thing is we need to know the scale. Millimeters to what? Centimeters to what? Decimeters to what? Meters to what? To decameters to what? To what? Kilometers. Okay? And then in feet, in the other system, what do we have? Inches. To what? To what? To what? How many? 12. How many? 3. How many? 5, 2, 8, 0. 5 tomato. And then you divide that by 3, and it gives you this, right?
1,007. That's cool. 5 tomato. That's awesome.
You like that, right? You guys understand that?
Yes, sir.
Well, remember this. Pay attention, little one. Last thing, I promise. When you're little, the first thing you learn is to what? Count. Forwards and what? And backwards. Then what do we do? Add and subtract. Then what do we follow? When we get groups of numbers and we put it in the same amount, we learn to multiply. Then the opposite of multiplication? Divide. But then we have this interesting thing that happens when we learn to divide. We have remainders. Right? So then we have dividing with remainders. Which lead us to fractions. Now what is fraction? A fraction of what? Of a pizza, of a clock, of a time, of many things. Then we have fractions. Right? And then we ask fractions of what? And then from fractions we go into what? Decimals. Right? And then what follows next? That's up to you. The moment that Devin finishes his book, we can go learn more. Understand? Now what happens is, I don't wait for you to become 25 years old to make your black belt in jiu-jitsu. If you want to become a black belt, right? The sooner the better. You gotta train hard. The more you want to learn, I'm waiting for you. Understand? Decimals. If you want to learn more after decimals, I'll teach you. But you gotta get that done. You gotta get to the long division. Because this is where some of you are right now. Right here. Once you learn that, we'll keep going. Just like jiu-jitsu, we have belts. In mathematics, we have belts. We have pre-algebra, algebra, calculus, trigonometry. Okay? All these fun things. Work your brain like chess, like jiu-jitsu. But you gotta get through it and you have to be good at them. You have to understand them well. Got it?
Yes, sir.
Everybody understand?
Yes, sir.
Okay? Who's gonna get here next? Devin is already there. Who's gonna get there next? You gotta finish those books. You gotta finish the workbooks.
I'm doing it.
Yeah, you're here. Devin is right now here. Okay? Who's gonna get there next? You gotta finish learning your multiplication table. You guys are right here.
I learned that.
Devin is right here. After Devin is done, we're gonna be learning some real cool stuff. He's this close to learning some real cool stuff ahead of his years. Some of you guys know more jiu-jitsu than some adults. You can do the same with mathematics. You can know more math than some adults do.
Dawson, sit like that.
Got it?
Sir.
Alright, let's go throw a push. Joy will part of it.
Yeah, that's what you were going to do.
Put the camera on side.